For section 7, we're looking at proportions. You've learned proportions before. Proportions are just ratios that are equal to each other. We'll talk more about that in a minute. Right now I want to talk about this problem. We're making beaded necklaces using this pattern right here. We have 2 red beads, the bigger ones, and then 3 blue beads, the little ones. Each set of 5 beads. So that means that right there would be a set of 5 beads. And then this is a set of 5 beads, this is a set of 5 beads. Each set of 5 beads adds 1 1/4 inches to the length of the necklace. How long do we want our necklace to be? 20 inches. So my variable here needs to be how many of these sets do I have? So I'll just call that X, the number of sets that I'm using in my necklace. I don't know how many sets it's going to be, but I do know that each set is 1 1/4 inches. I'm going to make that an improper fraction, not a mixed number. I don't like mixed numbers very much. So I'm going to make that what? 5/4 of an inch in one set. And X is the number of sets that I'm using. And I want my total length to be 20 inches. So if I multiply 5/4 of an inch times the number of sets that I use, I get my overall length, which I want to be 20 inches. So there's your equation. How can I solve for X? Multiply by the reciprocal. So I multiply both sides times 4/5. And I get X equals how much? 16 what? 16 sets, right? X is the number of sets used. I get X equals 16, so that must be 16 sets. Why would I do that? That's not what I'm looking for here. I want how many beads do I need of each type. Yeah, because now we know how many sets we're using, and we know that each set looks like this. So that means how many red beads do I need? 32 red. And how many blue beads do I need? 48 blue. So that would be the answer there. You got to figure out how many sets are in the necklace, then you know how many of each you will need to make that necklace. All right, now off to the side, or like below this, what is the ratio of red beads to blue beads? Just look at one of the sets. What's the ratio? 2 red over 3 blue. 2 to 3, that's right. What is the ratio of beads to length? Yep, 5 beads to 1 1/4 inches, which would be 5/4, not 1 1/4. But that's the idea. This is the hard part here, coming up with this. I understand that's hard, but this is the sort of math that you will typically do in your lives, and you'll think, oh, I don't never use algebra, but actually you do. This is the sort of thing that you do all the time in real life. All right, some vocab. Proportion. What is a proportion? What's that? No, I'm not going to say amount here. Yes? We're getting closer. There is an equal sign involved. It is an equation sometimes, but it doesn't have to be. What are equal? So we're going to use an equal sign to show that, right? But what is on the two sides of the equal sign? 2 ratios. So a proportion is a comparison of 2 ratios that are equal. your general proportions are going to look like this. A over B equals C over D. And that could be numbers, it could be letters, it could be an entire expression, but that's generally what a proportion looks like. What's the cross products property? Anybody know that one? What's that? Okay, yep. So multiplying diagonally across the equal sign. And when you do that, you wind up with a true statement. So multiplying diagonally across the equal sign results in a true statement. You'll wind up with an equation. So if I take my standard proportion that I'm looking at here, what that means is I'm going to multiply A times D, that's diagonally across the equal sign, and I'll wind up with AD. Then I'll multiply my other diagonal, B times C, equals BC. There's your cross products for a proportion. So let's just do a few examples here using the cross product property. You actually don't have to use the cross product property every single time you're working with a proportion. We'll talk about that later on, but for now I just want to practice using the cross products property. So I have this proportion sitting here. I want to eventually get m by itself. What should I do? Okay, you want to do cross products, so 7 times 12 is 7 times 10 would be 70. 84 equals 8 times m, 8m. Okay, now we got to solve for m. So what do we do? Divide both sides by 8. On the right hand side we get m. 84 divided by 8 looks like it reduces. What was it? Yeah, there's a factor of 4 in both of those. 21 over 2 is the answer. 21 halves is the answer. So what should I do on the second one? So what do I get when I cross multiply? Well, I like doing the x times 5 first. So 5x equals, which is 28. Okay, now what? Divide everything by 5. And we get x equals 28, what? Fifths. That one does not reduce, so that's our answer. All right, do the last one. So what do we do? So what do I get when I use the cross products property? Equals 55, okay. 55, 6. That does not reduce. The factors of 55 are 5 and 11. 5 is prime, 11 is prime. The factors of 6 are 2 and 3. None of those match. This does not reduce. A different way to solve this problem would be to just say, I got to get y by itself, right? So how do I undo dividing by 11? Multiply by 11. And when I do that, I have 11 times 5, which is 55, divided by 6. Same answer. Over here, I want to get x by itself. What do I do? Multiply both sides times 7. When I do that, I have 4 times 7, which is 28 over 5. Over here, I want to get m by itself. What do I do? Multiply both sides by 12. When I do that, I get 12 times 7, which is 84 over 8, and then I had to reduce that. So yes, you can do that, okay? That is the reason actually why cross products property works. It's because you are doing this math anyway. I'm about to show you that. All right, so there is the cross products property. It says if A over B equals C over D, then AD equals BC. This is what we just did. A times D equals B times C, okay? That is a property, which means you can use it. But why does it work? Well, let me rewrite this. A over B equals C over D. Anytime in math you have a property that's just given to you, like in 4th grade when they say, oh, you just do it this way, you leave it, change it, flip it, or whatever, keep, change, there's usually something going on there mathematically that allows you to do it, and you just never taught it. Well, here's why cross products property works. Let's say I wanted to get C by itself here. Remember in the last couple sections we've been solving equations for different variables? So let's say I want to get C by itself. What do I need to do? I got to multiply both sides times D. When I do that, what happens here? What happens here? Yeah, they're a fancy 1. They're out of there, right? So these form a 1 and they disappear. So now I have, you multiply this out and you get AD over B equals just C. So now let's say I wanted to get the AD by itself. What would I have to do now? Multiply both sides by B. And once I do that, on the left side, what happens to the B's? They're gone. They form a fancy 1. So what's left? AD equals CB or BC, because you can multiply in either order. And look what we have. That's the cross products property. Did we use cross products here and here? No, we didn't. But in the end, we wound up with AD equals BC, cross products property, okay? So we just proved that it works. All right, on these next 3 examples, we want to use the cross products property again. Maybe we don't have to, but we can. So on that first one, do we want to use the cross products property here? We need to, because of this x in the denominator, okay? So we don't really have much choice here. Actually, we do have a choice. If you know proportions well, then you know there's 3 things you can do to proportions to make equivalent of proportions, and then if you did that, then you would know that really all you had to do was flip it and multiply both sides by 8. But you didn't hear me just say that because you don't understand proportions well enough yet. We want to use cross products property, so what do I write? Equals 24, okay. Now what? Yeah, divide both sides by 4 and we get x equals 6. Before we go on, I want to take a look at this. We have 4/3 equals 8 over x. And I just figured out that x is 6. So now what I have here is 4/3 equals 8 over 6. Is that a true statement? Yeah, because I have 8/6, and if I reduce 8/6, I get 4/3. Okay? That's all proportions are. They're really just fractions that haven't been reduced on one side, and then fractions that either have been reduced or are reduced to something different on the other side. On the middle one, what do we need to do? Yeah, actually, you can do cross products property. If you did, you'd get 5y equals 9, and then you'd have to divide both sides by 5 to get 9/5 as your answer. But we just have this divide by 3 over here. So if you don't see it, you're stuck with cross products property. But if you do see it, then you can just multiply both sides times 3 and save yourself a little work. Y equals 3 times 3 is 9 over 5. That doesn't reduce, so that's your answer. And on the last one, yeah, we have no choice here. We have to cross multiply. So we get 5z equals 66. Divide both sides by 5, and you get z equals 66/5. This one looks really familiar to me. Didn't we just do this? Oh yeah, because it was 5 times 11, and then we had to divide both sides by 6. Huh. Okay. So, any questions on that? So whether you can avoid cross products on some problems or not becomes completely moot when you start to see problems that look like this. I want you to see that this is still a proportion. This is like A over B equals C over D, just like we've been using, okay? But now we have actual expressions in some of these problems. We need to learn how to use those. So the line I have right here, cross products are definitely needed on proportions like these. There's no other way to do it, as far as you know. So you got to do it that way. Cross multiply. We have 4 times b minus 8. So write that down. 4 times b minus 8 equals, cross multiply here, 5 times b plus 3. So now the proportion's gone, but we're left with an equation that we would have seen in like section 3, solving multi-step equations. So what do we need to do first here? Distribute. And when we distribute, we get 4b. What else? Minus 32 equals 5b plus 15. All right, now we know that we have to get all of the terms on one, all the variable terms on one side, all the number terms on the other. After I distribute, what do I have to do first? Combine like terms. If you look at the left side, are there like terms? No. If you look at the right side, are there like terms? No. Okay, so we're good to move on. I got to get all my variables on one side. That's where I usually like to start. So what should I do? Subtract 4b from both sides. Why would I not subtract 5b from both sides? Yeah, and that's kind of like my rule that I kind of keep to myself. If I move the 4b over here, then I'll wind up with a positive b. If I subtract 5b from both sides, move the 5b over here, I'll wind up with a negative b. And now that's just more chances to make a mistake. So I'm going to keep my b positive by subtracting 4b from both sides. What am I left with now on the left? Good, negative 32, make sure the sign stays with the number, equals what? Yeah, 5 minus 4 is 1, so we get 1b, or just b, plus 15. Now we subtract 15 from both sides. Nice. Negative 47 equals b. We've solved for b, so we're done. Second problem. I kind of moved a little bit too far over this way, but we can figure it out. What should we do? So cross products. First one is 6n equals 5 times 2n plus 4. We're just multiplying these two things together. So I'm going to write it down like I'm multiplying those two things together. It sets up a distributive property problem. That's fine. Make sure you write it down like a distributive property problem. Now what? So we get 6n equals 10n plus 20. Okay, now what? Okay. Combine like terms. We just distributed it. We haven't like terms to combine. No, so now what? Yeah, you could subtract 6n from both sides, but if I do that, now I got to move the 20 over here, and then I got to divide anyway. So in this case, I'm actually going to break my own rule that I just told you to follow, and I'm going to subtract 10n from both sides. The reason I'm doing that is because all of my number terms are already on the right side, so I want to get my variable terms on the left side. I'm saving myself a step by doing that. What do I get when I subtract 6n minus 10n? Negative 4n equals 20. Now what? Divide by negative 4. And n equals negative 5. You get the same answer if you did it the other way. It just takes one more step. All right, let me put up another fence here and go ahead and do the last one. So what do we do first? Okay, cross products. Do this one first, and what do we write? Okay, equals. Okay, I do want to see that step. I know some of you can do that in your head, but write it down. It gives you a nice spot to start off from. Okay, now what? So we get minus 10 equals plus 3. Okay, now what? So we just distributed. So we did. We distributed. Oh, we didn't distribute fully, did we? What happened? Yeah, this is a mistake that lots of people make. They forget to distribute that second thing in here, and this should be a minus sign here, right? Okay, I don't know why that disappeared. Distribute to both terms. 3 times x is 3x. There should be an equal sign. What is going on? Okay. Then plus 3 times 3 is 9. So make sure you are distributing to both terms. All right, that's a very common mistake. Okay, and now after we distribute, we combine like terms. Do we have any like terms to combine? No, so now we, all right, I got a positive 5x, a positive 3x. I got a number and a number. I got to move this x over here, so minus 3x, minus 3x. That gives me minus 10 equals 9. Now what? Add 10 to both sides. And we get, and now divide both sides by 2 and we get x equals 19 halves. That's your answer. Make sure you distribute fully to every term. All right. The original iPod, which was released in 2001, which was during your lifetime, I think. Is that true? You have an original iPod? I had an original iPod. I found it on the ground. Somebody dropped it. I actually had a friend who, when they first came out, showed them to me, and he said, I'm going to buy 250 of these and sell them because these are the future. And I said, you are crazy. I agreed. I knew that they were the future, but I did not agree with buying 250 of them and then selling them. He's pretty rich now. Anyway, I am not. I should have got in on that with him. The original iPod in 2001 had 5 gigabytes of storage. There was a time when we didn't even know what a gigabyte was. Nobody had ever heard of one. And now, like, your cell phone has almost a terabyte in it. You know what comes after terabyte? Close, it does start with a P. We'll probably figure that out in about 6 years when hard drives start having that on it instead of terabytes. It is crazy. Anyway, 5 gigabytes. You could hold about 1,000 songs if you use the MP3 format. You guys know what an MP3 format is, right? Okay, at least we haven't gotten past that yet. The latest model, which isn't the latest model anymore, has 160 gigabytes of storage. So the question is, set up a proportion to model this, and then how many songs in the MP3 format can the latest model hold? So I need to set up a proportion. To set up the proportion, you're going to have something over something equals something over something. Now you can do this a bunch of different ways, but you got to be consistent in how you set it up. So I'm going to show you how to set up a proportion right now. All the stuff across the top has to match, You got to be talking about the same type of thing across the top. You got to be talking about the same type of thing across the bottom. You got to be talking about the same type of thing on the left and the same type of thing on the right. Okay? So in this case, we have original iPod. We have the latest model of the iPod. Then we have gigabytes and gigabytes. Okay? Those are the things that we are putting into this proportion. So how do you want to set up the left side? Let's set up the information we have completely. You want to talk about the original? Okay. So then the left side is going to be original. And then the right side is going to be the latest model. Which means that all the information that I put on the right side has to come from the latest model, and all of the information that I put on the left side has to come from the original model. You don't have to do this on your homework. I'm just trying to show you now, okay? So you do want to write this on your notes. Now we got to come up with something to put across the top for both sides and something to put across the bottom for both sides. So what should our top number be here? We're looking at original, right? We have 5 gigabytes, could hold 1,000 songs. So what do you want to put on top? 5? 1,000? Doesn't matter. If we put the 5 here, though, then that means we have storage on top, which means we need storage on top over here as well. It's 160. So then here it's going to be, which is what? What is that 1,000? Songs. Which means we need songs over here, and we don't know what that is, so you call it a variable. You can call it S if you wanted to. I like X in this case, though. No particular reason why. Okay? Again, a variable is whatever you want it to be. So notice again, I have all of my original information here. I have all of my latest model information here. Once I had that locked in, and I put the storage across the top, then it had to be storage all the way across the top on both parts. And then my songs go on the bottom. I don't know why that looks like a 3. Songs on the bottom. Okay? Now it's set up properly. You want to do that mental analysis in your head to make sure that you have your proportions set up properly. Would it be okay if I had songs on top and storage on the bottom? Would it be okay if I had latest model on the left and original on the right? Yes, it doesn't matter, okay? As long as you set it up correctly, once you place those things, then you're good to go. Was that your question? I knew it. All right, so now what do I do? Cross products property. We have 5 times x equals something really big. 160,000. It's 160,000. Now we divide both sides by 5. X equals 32,000 songs using the MP3 format with a 160 gigabyte iPod. It's quite a bit of songs. You know how long that would probably take? Long time. It would take months to listen to all of those songs. So we got to set up the proportion. What do you want to put on the left? 8 ounces. And what? Below it? Okay. 97 milligrams of vitamin C below it. So on the right then, we're going to be dealing with what? On the right? That one's on the left. So now we're on the right. It's 12 ounces. And we don't know how many milligrams, so I'm just going to use X again. If you use C, that's fine. If you use V, that's fine. Whatever. Now what? So we get 8x equals 97 times 12, 1164. Divide both sides by 8, and we get x equals, what is it? 291? 291 over 2? So what is it really? 145.5 milligrams. There's your answer.